Hello, welcome to this lesson of Mastering Java. Here we're going to finish our discussion of the essential basic math methods in the math class, and we're going to talk about the inverse sine, inverse cosine, inverse tangent functions. So in the last, or I should say methods, in the last section we talked about sine, cosine, and tangent. That's when you take an angle and you figure out what the sine of that angle is, or you take an angle and you figure out what the cosine is, or you have an angle and you figure out what the tangent of that angle is. Now we're going to be going backwards and taking the inverse sine, inverse cosine, inverse tangent. And again, I'm not going to teach this whole concept to you. I have lots of math classes to do that. I'm just mostly trying to show you how to use it in terms of Java. So in terms of cosine, the aCosine is the arc cosine, returns the arc cosine of a value. The returned angle is in the range between 0 and pi. So it's telling you a couple of different things. It's telling you that the method name is called aCosine. That's frequently what is printed on calculators. Sometimes you'll see it with cosine and a little -1 in there to indicate that it's the inverse. Sometimes it has an arc cosine or an aCosine. So this is pretty standard terminology. It's also pretty standard that when you get the answer, it's going to give you an angle between 0 and pi. So it's like going backwards. It's like putting the answer in and getting back the angle there. So that's why it's called an inverse. Now for the inverse sine, we have something called aSin, which is the arc sine. We give it an answer in terms of a double value there, and the angle that we get back is going to be between -pi/2 and pi/2. So again, all of the answers coming back are in terms of radians. They're all in terms of radian measure. And then we have arctangent, same sort of thing. A tangent, stick a number in there and you get the angle back. In this case, it's telling you it's between -pi/2 and pi/2. Now the details of why it's pi/2, -pi/2, and all this stuff here is really a discussion for a math class. I'm telling you the facts. The facts are you give a double precision number in here, which is a decimal number, and you will get back an angle, which is a radian angle between this measure. For cosine, between these angles, for sine, and between these angles in terms of tangent. So let's go play around with that and show you what I'm talking about. We could do system.out.println like that, and then I can drop a semicolon in there, and then what I can do is math.aSin, arcsine, or inverse sine, however you want to represent it, open up a parenthesis, and it's telling me that I'm looking for a double precision number or a decimal that's of precision of a double precision variable. So again, I can create variables and drop them in there, or I can just type in a number. I can type in, for instance, 1.6. I can hit save, and I can drop that in there. Now notice that it's not going to work. It's going to give you not a number because the number that I typed in, whenever you're, okay, let me back up a little bit. For sine and cosine, whenever you take sine and cosine of angles, the only answers you can get back is going to be between -1 and 1. So whenever I go the backwards way, I can only give it numbers between -1 and 1. So for instance, if I go 0.8 like this, I will get a number back. If I give it -0.8, I will get an answer back. But if I go outside that range and make it -8.8, that's just not mathematically possible because of the way that the sine function is defined and the inverse sine function is defined. So if you ever see NaN, that's the reason why. But the basic use of the method here is just as simple as basically passing a value in there. And of course I can go over here to arc cosine and I can give it this number as well, and I'll get an angle back in radians, right? And then I can of course go and do tangent, and I can give it something back, which will give me an angle back in radians. All right. Now here's the nice thing about it. I like radian measure. Of course, I use it in all my math classes, and science and engineering is kind of built on radian measure, but sometimes it's nice to look at degrees. So what this tangent function is doing, just like the sine and the cosine function, is it's basically calculating the angle that corresponds to this number here, and that's what we call the inverse sine, and it's giving me that angle back in terms of radians. Well, what if I don't want radians? What if I want to represent the angle in terms of degrees? That's no problem. I can just wrap that entire thing 2 degrees, which is that nice method there. And what I will do is I will wrap the calculation here inside of this method here. So the inverse sine, arc sine, of -0.7 is right here, and that is sitting inside of the parentheses for the conversion to degrees. So now as I run this guy, that corresponds to -44 degrees. Or maybe I might do positive 0.65 or something like that. And I'll run this guy, and that'll be 40 degrees. Or maybe I want to do something like 0.95. And that'll be an angle of 71 degrees. So the basic idea for using inverse sine, inverse cosine, inverse tangent, otherwise known as arc sine, arc cosine, arc tangent, very, very simple. You just access the method math.aSin, aCosine, aTangent, drop the number in there that you get, and you're going to get a radian result. Of course, I can convert that to degrees very easily using the built-in functions of Java. Very, very simple to do. Very similar to how you would use it on a calculator as well. If you're confused about what is sine and what is cosine and what is arc sine and what is all that stuff, that is all covered in detail in my math classes, specifically the trigonometry and pre-calculus classes. So if you ever get stuck in programming and how, you're trying to do something with angles and you don't even understand what you're doing, you really need the fundamentals, which is not going to be covered in a programming book. It's going to be covered in a math book. Remember, Java is a tool, just like a calculator is a tool. You're not going to be a smart mathematician just because you know how to press buttons on a calculator. You need to understand how the math works. So I haven't really tried to teach you the math theory behind this. That's not the job of this course. I'm just trying to teach you how to use Java. So we have concluded this course, Volume 2 of Mastering Java. We've covered a tremendous amount of information from start to finish. And so we've covered lots of different control structures and looping structures such as for loop and if statements. We've learned how to make more complicated ifs and fors with code blocks with the brackets, the curly braces here. We've learned how to use the while loops and just all kinds of different control branching structures. We've learned how to use break statements and so on to control how the program flows. Those are sort of the essential bread and butter of how any programming language is set up, and that's what we focus on in first here. Then we took a little bit of a detour because I think it's sort of important for you to understand the richness in terms of the classes of the Java packages there and the classes and the methods that are available. And I think by going through this math exercise, the last several sections we've covered these math things. I've tried to show you how you might look some of it up on the documentation and how you might use it. So then 2 or 3 years from now, if you're trying to use a method in a different class, something that's much more complicated, you'll know where to go and you'll have some basic understanding, some basic idea of how to go get that information and apply it. Remember, learning programming is a journey. It's not something you're just going to learn and be done with. It's something that you're going to learn and then keep learning and keep learning and keep learning. It's much more like a sport where your skills build rather than just something you learn and you're done with. So keep that in mind, and then follow me on to Volume 3, which we'll be doing here in a short while, where we will continue getting into even more into the richness of how classes and objects work in Java, where you'll be able to create your own classes, create your own methods to do your own little subroutines inside of Java. We'll learn how to set all of that up in the context of classes and methods and all of that fun stuff, which makes programming much, much more useful and fun. So I'm Jason with CodeLearner.com. I hope you've enjoyed this set of lessons. Make sure you understand everything we've done here. Practice yourself. Open up your editor, type in some code, get comfortable with it, and then follow me on as we build your skills in Java from here on out. And I think you'll see that with more practice and more determination, you'll get better each and every time you try to code.